Okay, so this calculus 2 mean value theorem. By mean value, it doesn't mean your math teachers and the value that he's worth. Okay, so, yeah, I know, good try. I'm trying there on that one. All right, mean, anyway, all right, so mean means what? Average. That average value theorem, right? Okay, so now, all right, so let's start with Rolle's. Rolle's theorem. Okay, Rolle's theorem is actually interesting, and it only applies to one specific type of problem. Okay, it is defined on a closed interval from A to B, closed bracket, right? All right, so it's continuous A to B, differential on from A to B, right? On open interval from A to B, and f of A is equal to f of B. That's quite specific. That means that this and this are equal. My endpoints are the same values. Okay? My endpoints are the same values. So that's quite specific in the Rolle's theorem. Okay? Then there's at least one number C in the open interval from A to B in which that f of C is equal to 0. Okay? So now if I'm thinking about that, so now here's a little crappy sketch of what I have. All right, so what I'm trying to say is it's going to look something like this. If this is my A, this right here has to be my B, right? So it's going to be some function that's going to look kind of like this. It could be an x to the fourth. It could be, you know, other things where wonky both sides, but A and B are both going to give you the same y value. In this case, the y value is 0. Okay, and that means that it has to be a change of direction over here where I have a slope of 0 somewhere in there. And there could be a possibility of more than 1 0, but there should be at least 1 0 there. There's Rolle's theorem. Okay, so now find the x-intercepts of f of x and show that f prime of c is equal to 0 for some c belonging in the interval formed by the two x-intercepts. Now, first, let's figure out where's this equal to 0. Let's start with that. Okay? Let's start with that. So where is this equal to 0? So that would probably be the easiest thing to find, right? Yeah, so I'm going to see where it's going to be equal to 0. So let's go 0 equals x squared minus 5x plus 6. And I don't like blue because I can't write on the edge. All right, so there's going to be 0 is equal to now. Factor that. So it's going to be, let me see, a positive. If this is a positive here, that means that my factors both have the same sign. And because this is a negative right here, that means that both of them have a negative sign. So that means it's going to be an x minus what? 3 and x minus 2, right? Yeah? Okay, so there's the factoring of that one right there. So I come up with that. So in that case, I'm going to have an x equals positive 3 and an x equals positive 2. All right, so now, on my closed interval is going to be what? 2, 3. Okay. My closed interval 2, 3. So applying Rolle's theorem here says that there has to be a derivative where it's equal to 0 somewhere in between there. All right, so let's go ahead and take the derivative. So f prime of x is equal to 2x minus 5. So knowing that, I know that this has to equal 0, right? So I'm going to set my derivative equal to 0. So I'm going to say that 0 is equal to 2x minus 5. And therefore, I end up with x is equal to what?
5 halves.
5 halves. Positive 5 halves. Is that inside my interval of 2 to 3? Yeah. It's 2.5, isn't it? Yeah, it's right at 2.5. So look, we found C. We have the values now. Okay? So I found my closed interval from 2 to 3, and I found the x value where x prime of 5 halves is going to be equal to 0. Is that easy?
Yep.
Okay, anyone have questions over this? We're good? Okay. All right, so the next thing is going to be some of my favorite, mean value theorem. So, mean value says that the secant line in between your closed interval from A to B will have the same slope somewhere in there on that derivative. Okay? So my secant line is here to here from A to B. That's somewhere on the function, if you notice I have the blue line is the function right here, somewhere that function in between A to B should have that same slope of the secant line. Okay, so that last one we set it equal to 0. This one right here, I'm going to set it equal to the what? Say slope of the secant line. So this one's going to be set equal to the slope of the secant line. Okay, so now, again, same information. Has to be continuous, has to be differentiable. There has to be at least one number c in the open interval from which that it's equal to the slope. All right, so I need another page on this one. All right, so x cubed minus 3x plus 5. All right, f of x equals x cubed minus, what was it? 3x?
Yeah.
And my interval is from what?
-1 to 1.
Like that?
Mm-hmm.
Let me make sure I wrote it right. Yeah, condition the mean value, find the number of C guaranteed by the mean value theorem, interpret the numbers geometrically. All right, so let's take a look. So, this is written like this. So now whenever you see this, I know that it's going to be equal to at the end, right? So that means that at the left end, the bottom end of this is going to be a closed, right? If it's equal, it's closed. So bracket, -1, comma, and then again, equal again, that's closed. On the upper end is going to be a +1, bracket. Okay? So now, I have a closed interval there. All right, so now on that closed interval, I have to find the slope of the secant line. So it's going to be f of 1 minus f of -1 over 1 minus -1. Okay, this is the slope of the secant. That says secant, S-E-C. Man. So S-E-C-M. That's the slope of the secant. So let's see, f of 1 is going to be 1 minus 3 plus 5, that is 3, right? Minus. So -1 to the third, so that's -1 plus 3 and plus 5. That's going to give me, so look, -1 plus 3 plus 5. 7. Okay. 7 over 1 plus 1. Yeah? All right, did I lose anyone on any of this? Is everyone okay here? All right, so all I'm doing is find the slope of the secant line here. So now, right here, I'm going to end up with a -4 over 2, which gives me -2, right?
Yeah.
Okay, so I have -2 there. So my slope should be -2. So that is the m value. So this is the secant, okay, the slope of the secant line right there. Now, I'm going to find the derivative. So I'm looking for f prime. So f prime of x is going to give me 3x squared minus 3. Very good. So mean value said that it's going to be equal somewhere to -2, right? Somewhere should be equal to -2. So let's go ahead and plug this in. So I'm going to replace the f prime of x with -2. Very good. So I have -2 equals 3x squared minus 3. Add 3 to both sides, so I get 1 equals 3x squared, right? Okay. So divide by 3. So 1/3 is equal to x squared, right? Yes?
Yes.
Okay, so now, what do I do to undo the square? Square root, right? So it's going to be, I need a little bit more room for this. So it's going to be x equals plus or minus the square root of 1/3. And if I rationalize that, I'm going to come up with x equals plus or minus rad 3/3. Rad 3/3. Now, is that inside that interval? Yes, it is. It is inside that interval. Okay? So it is going to be inside the interval because it's less than, what? Let me see. So I'm just going to look at my calculator, approximate it, just so I give it a number for you guys. We're at 3 divided by 3. Yeah, it's 0.577. So now, is that inside my interval? So this, like I said, is going to be about 0.577. That's going to be in here, and I know that's going to be a plus or minus. Sorry. All right, that's a plus or minus. Those, it's inside my closed interval. So now, because of that, I have two places in which my function has a slope that is equal to the average slope. Does that make sense? Questions? It's pretty straightforward, right? All right, let's go back to here. All right, so find the number C guaranteed by the mean value. Okay. We did find the C, right? Okay, and interpret the numbers geometrically. So because of that, it was in between my two intervals. That means since I have two of them, that is equal to that value. Where am I looking at? Oh, right here. There we go. Come on now, come on. There we go. Okay, since I have two numbers that are equal to that value, so on that interval right there, that means I have like a little wonky x cubed in there, right? And because of that x cubed, I have 2 points there and there where it's going to be equal to that slope. Does that make sense? Okay, now let's take a look at what our graph is going to look like on that. There we go. All right. Okay, and my graph is here, so it was x to the what? X cubed, right? Cube. I still messed up that. X cubed. What was the next one? Minus 3x. Plus 5. Okay, let's look at my window. So menu, window. And I'm only going to be looking at from -1 to 1, right? Yeah. Okay. So I'm setting that up. Okay, so now what that means is from here to here, the slope of -2. That means that somewhere was at -0.5. So right here, this spot right here has a slope of -2. And this spot right here also has a slope of -2. That's what it means. Make sense? Yeah. Okay, good. All right. So there's that, done that. Mean value theorem to show that a car travels 110 miles in 2 hours must have a speed of 55 miles per hour at least once during the 2 hours. Okay, so now I have my times of t, right? Okay, so I know that I'm starting at, so my first time. So my time of 0, what is the output? How many miles do we travel at time 0? T, comma, miles. Okay, it's 0 and it's 0 miles, right? And time what? 2 hours, right? 110, right? Okay, so I have my time and I have my distances. Okay, so that means that we're looking at the rates in between here, right? Since we're talking about positions, when we take the derivative of the position, that's going to give me the what?
Velocity.
Velocity, right? And velocity, it's a changes distance over time, right? Velocity is the change of distance over time, but isn't that the exact thing as saying miles per hour? Yeah. That's what we're trying to get at, okay? So yes, we're actually doing a derivative of position here to actually get this. So the secant, oh man, brain work. So secant M is going to be, for this case, is going to be 110 minus 0 over 2 minus 0, right? Yes? Okay, so we come up with what? 55 miles per hour. So it's going to be my average is 55 miles per hour. And that's where we got that number for. Must have a speed of 55 miles per hour, somewhere in between there. Hey now. Okay. So we have that much information. So now we have to keep going with it. So now from here, I know that I'm going to have this right here. So do I have a function for this? No. I don't have function for it, do I? I just have points. So I have, by proving with my secant here, that it's going to end up, mean value, that it's going to be 55 miles per hour, somewhere in there. That's why we are verifying this per hour. Okay? Make sense? So this is a lot more basic than the previous problem. Yeah. We're just verifying it because using mean value, it's got to be equal to the average at some point of a closed interval, right? So yeah, that's what we got there. In words. Okay, yeah, I already put the words. There, see, there. All right. Two functions. F and G have the same derivative, then the functions differ by a constant, and the graph of this F is a vertical shift in the graph. So it's going to mean that they're going to have this, lines should be parallel. Okay, identify where it is increasing and decreasing. So let the function that is differentiable on the open interval from A to B. So where f prime of x is greater than 0 on that is going to be increasing, right? So if it's greater than 0, that's going to be a positive slope. E, there. Positive slope is increasing. Where f prime of x that's less than 0 is going to be decreasing, so that means that it's going to be a negative slope. That's what it's asking for. Okay. What was the last one? There we go. First derivative test. Using first derivative test, we determine at open intervals on which the derivative is positive or negative. Suppose that f is continuous on a closed interval from A to B, differentiable on the open interval from A to B. If f prime of x is greater than 0 on A to B, then f is increasing on the closed interval from A to B. If f prime is less than 0, A to B, it's decreasing, closed interval. First derivative test is valid if the interval is there to there. Okay? So we're going to have, increments, intervals for this. Okay. Determine where the function, blah, is increasing and where it is decreasing. So, first thing, let's go ahead and take the derivative of that. So f prime of x is going to give you what? 6x squared minus 18x plus 12. Okay? Now, what else do I have to do that? To figure out where it's increasing and decreasing. Now, think about it like this. So now, I'm gonna start with the parabola. So I'm gonna start with the parabola. I'm gonna, kick a soccer ball or some other. Okay. So yes, I just kicked something, okay? I just kicked it, and then all the way up until this point right here, it was increasing, wasn't it? It was increasing until it gets to there, right? So the change in direction from a positive to a negative is at 0, right? When my slope is 0. So when I get my slope 0, I know that there should be a change in direction. Okay, there should be. But sometimes it could be just like this, or it also could look like this, right? So it could be like that. But, you know, I got some good skills with the football, but I don't think I could actually make it do that. Okay? So like put so much spin on it that it all of a sudden, you know, it levels out to 0, then goes back up again. Yeah, I don't got that skill. I'm working on it, okay? I'm working on it.
What if you bounce it off?
That's called a knuckleball.
Yeah, there we go. There we go, right there. So, yes, that's like Beckham right there. Yeah, okay. Listen, everyone could talk crap about him, but, you know, not that I like him, but, you know, the guy was still good.
No,
Kind of like that Rodolfo guy, too. Yeah. Yeah, anyway. All right, so now, what do I have to do with this information now? I told you everything, and now what do I do with it here?
Set it equals 0.
Excellent, set it equals 0. 0 equals 6x squared minus 18x plus 12. Now, we have to do what with that now? Say factor. Factor. Take out a common factor of 6, right? Because I like reducing this. So it's going to be 6 quantity x squared minus 3x plus 2. So again with the signs, I get a positive over here and a negative here. So positive says that the signs are the same. Negative says that my signs are both negative. So that means that I'm going to have 6 times quantity of x, let's see, minus 2. Yeah. And x minus 1 is equal to 0. You guys agree? Okay, good. All right, so now I have two places where it's going to be equal to 0. That's going to be x is equal to positive 2 and x equals positive 2 and x equals positive 1. So let's take a look at a number line that I'm going to have somewhere in there. Okay, somewhere in there. Okay, my number line. What was my original function?
2x cubed minus 9x squared plus 12x minus 1.
Minus 1?
5.
5. Okay. Okay, so we know that f prime of x was 6x squared minus 18x plus 12. And we know that on a number line that I have now, that it's going to break it up into certain parts. So I had my points at 1 and my points at 2, right? So if this is continuous, I only have two places on here where my derivative, my slope is equal to 0. So that means that it's going to be changing directions in between here and here. So all I have to do is plug in numbers for this. Because I'm looking for, is it a positive or is it negative? If it's positive, it's increasing. If it's negative, it is decreasing. So I'm plugging in, let's plug in the number 0. So let's take a look. So let's say f prime of 0 would be what? It's going to be positive, right? So it'd give me 12. So that is positive. So all this here, everything on the left-hand side of this is going to be positive, right?
Yeah.
So let's go back to that kicking the football theorem. If it's increasing to 1, okay, what should be happening on the other side of 1? It should be decreasing, right? So unless it's one of those weird wonky things, Okay, but it is possible, but I want you guys to see this. So right here, there could be a change in direction here. So it could stay positive or go down to negative, right? Okay, so now, find a number in between 1 and 2. Let's just say 3/2. So f prime of 3/2. What's that, 6? Yeah, okay. Minus 27, minus 12. So what's that going to be? Did you guys do all the math on this yet? Or just stared at me awkwardly? What'd you get?
I got -3/2.
Negative 3/2?
Yeah.
Seems right. Okay, so negative 3/2. So we end up with a negative, which is and that means that over here, all the piece, that whole increment in between here is going to be negative. It's all down here, right? Okay, so now we got to pick a number on the other side, don't we? So pick a number on the other side. So the number on the other side is going to be f prime of, let's say, 3. 9 times 6 is 54. Okay, let's see. 54 minus 54 plus 12, which is a positive 12. Did you guys get 12 also? Okay, good. Because I'm kind of winging it here on this one. So hopefully my mental math is working. All right, positive. So what does that tell me in between here? So what do you think my graph of this should look like now? So over here, so it should be going up. So I'm gonna sketch this right here. So up to here, right? And then it's going to be down here to here. And right there, it goes back up. So that's what my graph of my function, so this would be my f of x function, should look something like this, right? That's using the derivatives, the slopes, to tell me where I'm going to have my mins and maxes, somewhere in there. Okay? Does that make sense? And I was able to sketch it using that information. Okay, so where are we at? So, how many more of these do we have? Ah, crap. Yeah, that one's going to be time. Alright, so I guess I will finish this one tomorrow. Monday. So, I want to give you guys time to start working on this. Alright, don't forget, like, subscribe.